This is week 19 on the higher paper, so we've got non-calculator again this week, and these are all the topics that we're going to go through. All the odd numbers this week, and the even numbers will be next week. 41 marks, so about half a past paper. Normally they're out of 80, and these are all the Sparks codes if you do have access to Sparks, to just go over anything that you might find a little bit tricky. Question number 1, work out 3.67 times 4.2, a really classic non-calculator question. Now I'm going to do this one of two ways. Now I'm going to show you both of those methods, and you need to pick one of these, decide which one is right for you. But by all means try it both ways, just see which one you prefer. So if you're doing traditional column method, take the decimal points out. Let's just do 367 multiplied by 42. When you are multiplying, the place value does not matter until the very end when we put that decimal point back in. Okay, the digits aren't going to change. If you did 367 times 42, you're going to get the same digits as if you did 3.67 times 4.2. So just take the decimal points out and we'll worry about where that goes at the end. 2 times 7 is 14, so 4 carry the 1. 2 times 6 is 12, add that 1 is 13, and 2 times 3 is 6, add that 1 is 7. We're now moving over to the 4, but it's really 40, so we need to remember to put this 0 here to hold the place value. 4 times 7 is 28, 4 times 6 is 24, add the 2 is 26, and 4 times 3 is 12, add the 2 is 14. We're then just going to add those together. 4 add 0 is 4, 3 add 8 is 11, so 1 carry the 1, 7 add 6 is 13, add the 1 is 14, and then 4 add 1 is 5, and we've just got a 1 there. So 1, 5, 4, 1, 4. Now we are expecting this answer, given that this is approximately 4 times approximately 4, the answer should be somewhere around 16. 4 times 4 is 16. So what would be a sensible answer? Well, it would be sensible to say that the answer was 15.414. That makes sense. That seems about right. That's method number 1. Method number 2 is called the lattice method. It's got lots of different names actually, but I always call it the lattice method. You're going to draw a table. There is 3 boxes going across because that first number has 3 digits, 3.67. And 2 boxes tall because that second number is 4.2. And we're timesing. You're going to split every box diagonally. And a lot of people find this method easier just because there's less carrying involved. And when I see both of these on GCSE, I do find that this one goes wrong less often, but it's entirely up to you, whichever one you find easier. So we're just going to do the number at the top times the number at the side. So 7 times 4 is 28. So I'm going to put 28 like that. 7 times 2 is 14, so that goes like that. 6 times 4 is 24. 6 times 2 is 12. 3 times 4 is 12. And 3 times 2 is 6. You're then just going to add down each diagonal section like this. So in the first diagonal section, we've just got a 4. And then 8 add 1 add 2 in that next section, that's 11. So 1 goes here, and then we carry the 1 into the next diagonal section. 6 add 1 add 1 add 4 add 2. That's going to add up to 14. So 4 goes here, and we carry the 1 into the next diagonal section. 2 add 1 is 5. And then we just have a 1 in that last diagonal section. The nice thing about this method is you can go down with 1 decimal point and across with the other. And wherever they meet, you're going down that diagonal, and that tells you where to put the decimal point. So either way, the answer was 15.414 for 3 marks. Part B, we're doing 59.84 divided by 1.6. Now with a division, we don't really want to be dividing by a decimal. The first thing I would do is write it as a fraction and then say, well, I'd rather that denominator was 16. I'm happier dividing by 16 than I am divided by 1.6. What have we done there? We've times the denominator by 10. So we also need to times the numerator by 10. And what that does is it keeps the fraction the same. Okay, keeps the fraction the same. So that is the same sum. You don't need to divide by 10 at the end because you've times the top and the bottom. That is an equivalent fraction, equivalent sum. Good, now we're going to do 598.4 divided by 16, and I would probably just do that using the bus stop method. So 598.4 divided by 16. There's absolutely no need to do long division here. We can just do short division, just like normal. You might find it helpful to write out the 16 times table. Again, it doesn't matter if this takes you a little bit of time. 16, 32, 48, 64, add on another 16 is going to be 80, add on another 16 is going to be 96, add on another 16 is going to be 112. Let's see if that's enough for now. Okay, 16 going into 5 doesn't go. 16 into 59, we can see we can fit 3 in. And we've got 11 left over, because I've got to 48 and I've got 59 to use up. So 11 left over means 118, and we can see 1, 2, 3, 4, 5, 6, 7 would fit into that, with 6 left over, and 16 into 64 is, 4, sorry. There we go, 1, 2, 3, 4, and that decimal point here gets moved up here as well, so your answer is 37.4. And that makes about sense. I'm looking at this sum and I'm thinking this is roughly 60 divided by 2. So that's a sensible answer in my mind. Okay, next question. Question number 3. Work out 4 1/5 minus 2 2/3. Give your answer as a mixed number. Now when we're adding and subtracting, multiplying or dividing, we want to make these fractions top heavy. And to do that, you're going to do big times bottom, add on the top. Big times bottom, add on the top. 4 times 5 is 20, add the 1 is 21 over 5 minus, and again here we're going to do big times bottom, 2 times 3, which is 6, add on the top, which is 8, so 8/3 there. To subtract or add fractions, you need to make the denominators the same. So I'm looking for a number that's in the 5 times table and the 3 times table, and that's going to be 15. Whatever we do to the bottom, we also need to do to the top. So I've times that by 3. I also need to times the numerator by 3, and that would be 63. With this fraction, I've times the denominator by 5. I also need to times the numerator by 5, and that would be 40. You can then go ahead and subtract. So 63 take away 40 is 23 over 15, which is 1 whole, because 15 goes into 23 1 whole time, with 8 left over out of 15. So there's your answer, 1 and 8, 15. Always check if this fraction can be cancelled down, but in this case it can't, so that is your final answer. Question number 5. Rosie, Matilda and Ibrahim collect stickers. The number of stickers Rosie has to the number of stickers Matilda has to the number of stickers Ibrahim has is in the ratio 4 to 7 to 15. Ibrahim has 24 more stickers than Matilda. Ibrahim has more stickers than Rosie, how many more? Now with these, I like to do little lines for ratio. So 1, 2, 3, 4 piles for Rosie. 1, 2, 3, 4, 5, 6, 7 little piles for Matilda. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 little piles for Ibrahim. And we know that the number of stickers on each of these little lines has to be the same. Now, if Ibrahim has 24 more stickers than Matilda, he's got 8 extra little lines. Okay, so Matilda has 7 little lines and Ibrahim has 15 little lines. So we know that if he's got 24 more stickers, they must be on the extra 8 lines. So therefore we know that 8 parts is equal to 24. 8 of those little lines must be worth 24. And if we divide that by 8, we get 3. So I know that each of these little lines has 3 on it. And we could fill that in for all of them, but we know now how much is on each line. So I know that for Rosie, she's got 4 piles, each with 3 on them. So Rosie has 12 stickers. For Matilda, she has 7 piles, each with 3 on them. So she has 21 stickers. And Ibrahim has 15 piles, each with 3 on them. So he has 45 stickers. How many more stickers does he have than Rosie? So we're comparing Ibrahim to Rosie. 45 take away 21 is 24. So 45 minus 21 is 24, and that's how you would get your answer. Okay, question number 7. The diagram shows a cube with edges of length x and a sphere of radius 3. The surface area of the cube is equal to the surface area of the sphere. Now this is a massive clue to make an equation. We're going to do the surface area of this is equal to the surface area of this, and we're given the formula here for the surface area of a sphere. Okay, so the surface area of the cube, we know that there are 6 identical faces on a cube. Every single face is x wide and x tall. I want the area of all of those faces added together. So each face has an area of x squared because it's x wide and x tall. So there are 6 identical faces on a cube, so I know the surface area is 6x squared. And that equals the surface area of the sphere. Now that is given by 4 pi r squared. So 4 times pi times 3 squared, and that's going to be 6x squared is equal to, now remember 3 squared is 9, timesing by 4, 36 pi. We then just want to simplify this equation, and I can divide both sides by 6. So x squared is 6 pi, and then to get x on its own, which is what they want in this equation here, we're going to square root both sides. So x is the square root of 6 pi, and that's worked out that k is 6. And there we go, that's 4 marks for that one. Very nice. Okay, question number 9. Write down the value of 7 to the power of 0. So for the purpose of GCSE, anything to the power of 0 is going to be 1. There we go. 7 to the power of 0 is 1. Find the value of 3 times 3 to the power of 6 times 3 to the power of minus 6. When we times, we add the powers. A 3 on its own is the same as 3 to the power of 1. So I'm doing 1, add 6, take away 6. And that's going to be 1. So there we go. All together, it's just 3 to the power of 1, but we wouldn't bother writing 3 to the power of 1. We would just write 3. Really important when it says find the value. If the answer had ended up being 3 squared, we would want to write 9 as the answer. Find the value means what is the actual numerical answer. Question C, find the value of 2 to the power of minus 4. Now when a power is negative, it means you're going to take the base number and do the reciprocal. So the reciprocal of 2 is 1 over 2. We've still got to raise that to the power of 4. So 1 to the power of 4 on the top is 1, and 2 to the power of 4 on the bottom is 16. So 1 over 16 is your answer there. You can do 2 to the power of 4 and then do the reciprocal. That's absolutely fine. Find the value of 27 to the power of a third. Now when the power is a fraction, you root by the bottom, and then do the power of the top. So in this case, it's just going to be the cube root of 27. We'd then raise that to the power of 1, but that would keep it the same. So the cube root of 27 is asking you something times something times something that makes 27, and that is 3. So 3 is your answer there. Question number 11. The diagram shows 2 rectangles, A and B. All measurements are in centimetres. The area of rectangle A is equal to, because this is really quite similar to the one we've just had, the area of rectangle B. Find an expression for y in terms of w. So area of a rectangle is base times height. So to work out the area of this one, it's going to be 6 lots of 2w add y. That's the area of that rectangle. And that's equal to the area of B, which is 7w times 3y add 6. Again, all I've done for both of those is base times height. Find an expression for y in terms of w means we want it to be y equals, and then everything else on the other side in with just w's in that expression. So we want y on its own and everything else on the other side. Let's start by expanding these brackets. That's going to be 12w add 6y is 21wy add 42w. I'm doing this times this and this times this, this times this and this times this. There we go. Now everything with a y we want on the left or on one side, doesn't really matter, and everything with a w we want on the other side, or everything else we want on the other side. So I'm going to start by taking 21wy away from both sides. That has a y in it, so I want it on the same side as the 6y. And I'm also going to take 12w away from both sides. That doesn't have a y in it, so I don't want it on the same side as the things that have y's in them. So that would leave me with 6y minus 21wy equals 30w. This is gone, and you've cancelled this down to be 30w. They are like terms, so that can come off. Now I want y to be the subject of the formula, so I just want to take the y outside here. 6 minus 21w is what you'd be left with, equals 30w. And then we're going to divide by that bracket, so y equals 30w over 6 minus 21w. And that would be your final answer. You now have y in terms of w, so y equals 30w over 6 minus 21w. And you might have factorised the bottom as well, with taking 3 out. That's absolutely fine. Oh yeah, we can simplify the whole thing. Let's do that. So let's divide everything by 3. So you might have written it as, it doesn't say give it in its simplest form, so you're absolutely fine not to, but y would equal 10w over 2 minus 7w, because everything, all 3 terms there, are divisible by 3, so you can cancel down that fraction. Either of those would be absolutely fine, but yeah, you don't need to do the extra step. Okay, question number 13. Ted is trying to change 0.43 to a fraction. Here is the start of his method. He's done x is 0.43 recurring, perfect. 10x is 4.34 recurring, yep, that's absolutely correct. And then he's subtracted them away from each other. Now, this is fine, this is fine. The problem is that what he's done is he's got 434343 like this, ... And then when he's done 10x, he's got 4.343434 ... So what's happened here, when he then subtracts them, he hasn't got the right numbers lined up underneath. So he should have done either x and 100x, because 100x, if you look, if we'd have times that by 100, you'd have moved it over 2 place value columns, and it would have ended up being like this. And then when you subtract, you're going to cancel those numbers out. So there's lots of different ways you could write that. Let's say he has not correctly lined up the values, so they would not cancel when you subtract. Or you could say something along the lines of, he should have done x and 100x, or he could have done 10x and 1000x. That would have worked as well, as long as the things that he did were 2 place value, like 100 times bigger than each other, then that would have been absolutely fine. There you go for that one. Okay, question number 15. Show that 4x add 3 over 2x add 3 over 5 can be written in the form ax add b over cx, where a, b and c are integers. So to add fractions, we need to make the denominators the same. And the easiest way to do that is to multiply them together. We don't know what x is, but we know that if we times them together, we'll definitely get a number in both of their times tables. So on the denominator, I'm going to put 10x. I've multiplied them together. Because I've times this by 5, I also need to times this by 5. So that's 5 lots of 4x add 3. Add, and then for this second fraction, I've times this by 2x. So I also need to times the top by 2x. And that's going to be 3 lots of 2x, or you can just write 6x there, that's absolutely fine. Now a lot of you like to call this the upside down picnic bench, because it kind of makes this shape, and when you're adding or subtracting fractions, that will work. So adding or subtracting, if we were timesing, we just do top times top, bottom times bottom, and if we were dividing, we would keep the first fraction the same, change the divide to a times, and do the reciprocal, flip the second fraction. Okay, so let's cancel this down. I've got 20x add 15, add 6x from this, all over 10x. And that is 26x add 15 over 10x. And that's as far as we can go. No common factors with all 3 of those terms. So we're all good. And that's exactly what they've asked me for. Something x add something over something x. So we know that we are Yeah, looking like that's going to be correct. Okay, question number 17. On the grid, show by shading the region that satisfies all of these inequalities. Now, if we had greater than or equal to, or less than or equal to, we're going to be drawing these with a solid line. But because we have greater than and less than, we draw that with a dotted line. I remember my year 11 teacher saying to me, if you can't quite reach it, you can't draw it properly. Or when you think about a number line, if you can't reach it, you can't colour it in. So the dotted line is like, oh, can't quite get there, can't reach it. I don't know, for some reason that stuck with me all these years. So there we go. So we're going to use dotted line for these. So I'm just going to change my line to be dotted. Now what we want to do is draw this when it's equal. So I want to draw 2y add 4 equals x. And then I'll worry about what side to shade afterwards. So I can change this, and I'm going to change this, to be 2y minus x equals minus 4. And I've just rearranged it, so I've got the x and y on the same side. What that enables me to do is the cover-up method. So if you would like to know when a straight line crosses the x-axis, you make y 0. And so if I make y 0, that term would be 0. And then I've got minus x is minus 4, so x must be 4. So therefore we know it crosses the x-axis at 4, which is here. I then, if I want to know when it crosses the y-axis, make x equal 0. And if I make x equal 0, that would be 0. 2y would equal minus 4, so y would equal minus 2. So you're just solving the part of the equation that you've got there. And there you go. Once you've got 2 points, you can then join them up with a dotted line like that. There we go. So that's that equation. Now I would like 2y minus x to be smaller than minus 4. 2y minus x to be smaller than minus 4. That's the inequality that we're trying to shade. So what I would do is pick a point, and the origin is always a really good point to use, because at the origin you've got x is 0 and y is 0. So I would like to check, does 2 lots of 0, that's my y coordinate, take away 0? Is that smaller than minus 4 or not? Well, 2 lots of 0 take away 0 is 0. Is 0 smaller than minus 4? No, it is not. And so therefore, that point and every other point on that side of a line is no good to me. And if you checked any point on this side of that line, they would all work. So you just need to find a point where it doesn't work. My dotted line should have gone all the way to the edge there, but hopefully you can see that. That's absolutely fine. We'll just carry it on like that. There you go. Okay, next line. X needs to be less than 3. So again, I'm going to get my dotted line, and I'm going to draw x equals 3, which looks like that. Now I want x to be less than 3, and that means I need to shade everything I don't want, which is all of the values of x that are bigger than 3, which is everything on that side of the line. There we go. And then last but not least, I need to draw this. And again, I'm going to draw y equals 6 minus 3x, which is the line with y-intercept 6 and a gradient of minus 3. So the line y equals 6 minus 3x is going to cross at 6. And for every 1 across, it's going to go down by 3. So 1 across, 3 down, 1 across, 3 down, 1 across, 3 down, 1 across, 3 down, and so on. And again, we're going to join that up with a dotted line, and we're going to check and see which side we need to shade. Now, we need to shade the side where y, well, we want y to be less than 6 minus 3x. All your big values of y are up here, and all your small values of y are down here. So if you want y to be bigger, you know you're going to be shading under the line, because you don't want that. And if you want y to be smaller, you're going to be shading over the line, because you want what's under. I hope I said that the right way around. Okay, so we want y to be less, therefore we're going to shade on top of the line, above the line, because that's where all of your bigger y values are going to be, up there. And so it's shading like that. So the region that we're left with, we normally put a big capital R in it. Yep, there we go. And that is going to be that region there. I'm just going to clean that up because I'm annoyed with myself for going over the line there. There we go. That region there, that is the region that satisfies all of the inequalities. Okay, question number 19, and we have surds. Show that 8 add root 12 over 5 add root 3 can be written in the form a plus root 3 over b, where a and b are integers. So integers are whole numbers, remember. So the first thing I'm going to do is look at, no, I'm not. I'm going to rationalise it as is. So 8 add root 12 over 5 add root 3. We can never leave surds on the bottom of the fraction. If you have a surd on the bottom, we need to get rid of it. Now, if it was just root 3 on the bottom, then timesing by root 3 over root 3 would get rid of that surd, because root 3 times root 3 is 3. But here we've actually got two terms on the bottom. So if I just times this by root 3, yes, this times this would become 3 and get rid of the surd, but you'd also have to times it with the 5, and then you're going to get 5 root 3, and you haven't actually got rid of the surd. So what we need to do in this situation is times by something called the conjugate, which is going to be the same thing but the opposite sign. So if this was a minus, you times by the same thing but with a plus, and if this is a plus, you times by the same thing but with a minus. On the top and the bottom, because I want to keep this fraction equivalent. Right, timesing this out then. 8 times 5 is 40. 8 times minus root 3 is minus 8 root 3. Root 12 times 5 is 5 root 12. And root 12 times minus root 3, because they're both surds, you can times them together, and that's going to be minus root 36. Now, on the denominator, because we're timesing by the same thing but different signs, something really cool happens. 5 times 5 is 25. 5 times minus root 3 is minus 5 root 3, but then we've got root 3 times 5, which is plus 5 root 3. And then we're doing root 3 times root 3, or minus, which is minus 3. Okay, and these two will always cancel out if you use that setup. Now on the numerator, I've got 40 minus 8 root 3, add 5 root 12 minus 6, because that's the square root of 36. And on the denominator, I've got 25 take away 3, so 22. Now 40 take away 6 I can do, and I can simplify this bit. My problem now is with root 12. Now root 12 has a square number factor in that 12 has a square number factor, and we can split that up to be root 4 root 3. The square root of 4 is 2. So root 12 can actually be written as 2 root 3, and that's simplifying surds if you're not sure what I did there. So I've got 34 minus 8 root 3, add 5 lots of 2 root 3, because we have got that 5 in front there. All over 22. So that's 10 root 3. So if I've got minus 8 root 3 and I'm adding 10 root 3, my final answer is 34, add 2 root 3 over 22. Not my final answer, because everything is even. So I've got 17, add root 3 over 11. That's your final answer there. That's in the format they asked us for. 17, add root 3 over 11. Hopefully that makes sense. That's rationalizing surds. The harder version of that is what you were doing there. Okay, question number 21. The functions f and g are such that f of x is 3x squared add 1, but x has to be positive, and g of x is 4 over x squared, and again x has to be positive. Work out g of f of 1. Now this is a composite function, and we work from the inside out. So this is asking us to put 1 into the function f, and then take that answer and put it into g. So we're going to start by putting 1 into f. f of 1 is 3 lots of 1 squared, add 1. 1 squared is 1, then times it by 3 is 3, add the 1 is 4. So f of 1 is 4. You're then going to take that 4 and put it into g. So g of 4 is 4 over 4 squared, which is 4 over 16, which is a quarter. So a quarter is the answer they're looking for there for 2 marks. The function h is such that h is f of g minus 1. So it's the inverse function of fg. Find h of x. So we need to do the function f of g and then find the inverse of that. So let's start by finding f of g of x. Let's start by finding this function. That means we're going to put x into g, and then we're going to take that whole function and put it into f. So x into g is going to give us 4 over x squared. We're then going to take that 4 over x squared and put it in to f. So that's going to be 3 lots of 4 over x squared squared, add 1. So you're putting g into f, and then we're going to do the inverse, but let's sort it out first. So I've got 3 lots of 16 over x to the power of 4, add 1, because we would square that first, and that is 48 over x to the power of 4, add 1. Okay, that's f of g of x. Now I want the inverse of that function, and to get the inverse, the easiest way to do is to make y the subject of the formula, and then rearrange the formula to get x on its own. So that's going to be y minus 1 is 48 over x to the power of 4. So I now want to switch those round, times the x to the power of 4 up, and bring the y minus 1 down. So x to the power of 4 is 48 over y minus 1. And I then want to do the fourth root. So x is the fourth root of 48 over y minus 1. And then all we do is switch those letters back round. So to make y the subject. So h of x, which is our inverse function, is the fourth root of 48 over x minus 1. That is the final answer squished in there, and that was very much grade 9, last question on the paper. We had 41 marks altogether there. I think that last question was absolutely grade 9, although hopefully lots of you will have found this one accessible. And then yeah, rationalizing surds, that's very much grade 7, 8, that one as well. So hopefully you found that helpful, and let me know in the comments if you've got any questions at all. I'd be happy to help, and I will see you guys next week for week 20.